Hello, my name is Natalia and I'll be showing you my work. Music is generally described as simply relaxing or stimulating, but that is quite reductive. Music is widely used as a non-invasive tool for modulating physiology, so why not try to introduce it into cardiovascular therapeutics? As such, my research questions became, can we identify which music structures lead to changes in physiology, and can we use algorithms to identify the way that the body entrains to the music? First, we had the Heart of M study in which 127 participants had their signals recorded whilst they listened to 9 different tracks played on a reproducing piano. The 9 tracks were made from a set of 30 which were created from modulating the loudness and tempo of 8 original pieces. And then we identified their phrase arcs, which denote the section changes in the music, using the Bayesian algorithm, which you can see on the bottom left. Afterwards, we compared the music and the physiology by looking at the similarity between the envelopes, and we did that using Erdmüller's distance. We also calculated the statistical significance by using surrogate data testing. We also looked at correlations between the metrics, and the key finding was that physiology aligned to the musical structure above chance, and that this effect was stronger in the tracks that had more predictable phrase structures. Afterwards, we looked at heart rate variability, or HRV, which is a metric of cardiac fitness, generally with higher values indicating better health. And you can see on the top left that for the variability during music, it increased significantly. But on the other hand, when looking only at the mean of the actual values, during music there wasn't a significant change, but after music listening, there was an increase in the signals which show a parasympathetic activation, which indicates relaxation essentially. Afterwards, we also looked at vocal music, so when people were actually singing. And whilst doing this, we also validated and extended a foundational study in the field. And we looked at Verdi opera excerpts. We analyzed the time frequency coherence between the music and the physiology for all participants, within and between participants. And what we found, just like with the previous data set, is that there was higher coherence for the track that had more predictable structure. And also you can see highlighted on the bottom left the fact that where there was a big change in the music, there was consistently a high coherence. Importantly, we also looked at objective boundaries, so the ones annotated based on the music, and we saw that these were better aligned with the physiology changes than the personalized ones, which were the ones that people annotated themselves. And essentially together, all of these findings showed that the music physiology coupling follows a predictable pattern in response to how it reacts to music and the mathematical structures in music. And this hopefully will give us the route towards personalized music-based cardiovascular therapies.